What if you have negative exponents? How do you add and subtract those? So far, all the examples we've looked at, every problem has positive exponents. But that's not always the case with scientific notation. Remember, scientific notation is used to represent really, really large numbers, but it's also used to represent very, very small numbers, like those decimals that represent the size of an atom or the size of bacteria. So we want to look at a couple of those examples, all right? So that's what we're going to do next. All right, this looks like a lot of wording, but it's not. What I want you to do is to write down example 1 here and make a new subtitle that says add and subtract scientific notation with negative exponents. And then write this as example 1. So go ahead and pause the video, make a new subtopic, add and subtract with negative exponents, and then write down a new example number 1. This will just go on the same notes. It's just looking at the negatives now, okay? So pause the video and do that. All right, I'm going to go ahead and start talking. I have a little number line up here that we're going to use when we're comparing numbers. It helps us to remember as negatives are on the left, the positives on the right, and which values are greater or less. So the rules are just the same. Same step 1, they have to have the same power of 10. If they don't have the same power of 10, you change the smaller one to equal the larger one, and then you move the decimal the amount of times that you added to that power. So we're going to do the same thing. It's just we have to now think in terms of negatives. So for this first example, we have 1.524 times 10 to the negative 6 minus 3.5 times 10 to the negative 8th. All right, so for this one, we want to look at our powers of 10. And I have one that is a negative 6 and one that is a negative 8. So when you are thinking about negatives, which one's larger, negative 6 or negative 8? Okay, and that's what you got to think. So that's one of the number lines here. So remember, the further on the right that the number is, the greater it is. So negative 6 is going to be on the number line about right here, and negative 8 is going to be further out. It's going to be less. So this is the smaller one, is the negative 6. So we're going... I'm sorry, the smaller one is the negative 8 because negative 6 is the larger one. I'm sorry. Negative 6 is the larger value. So we want to make the negative 8 become a negative 6 by adding 2. All right? So if we add 2 to negative 6, if we add 2 to negative 8, it becomes a negative 6. All right, so I need to move this decimal 2 spaces to the left. This becomes 0.035 times 10, and negative 8 plus 2 is negative 6. You always want to do that math and make sure. Now they have the same power of 10. Now we can do our operation that was original. And notice it is a subtraction. All right, so I'm going to line them up. This 1.524 has to go on the top because it's subtraction. 0.035 on the bottom. And now I'm ready to subtract. I'm going to have to borrow. 14 minus 5 is 9. 1 minus 3, I'm going to have to borrow again. So now I have 11 minus 3, I get 8. 4 minus 0 is 4, and 1 minus 0 is 1. So my answer is 1.489 times 10 to the negative 6. All right, so it's the same exact rules we were doing before with the positives, but when you're looking at the negatives, you got to think about the number line and which value is the least. So in this case, negative 8 is less than negative 6, so that's why the negative 8, we always change the lowest one to become equal with the higher one, okay? Let's do another example on the next page.